Hi, folks. Welcome back. I hope you're all doing well. So, I was curious to see how LLMs are doing on math problem solving. And so, I came to check out the GSM8K leaderboard. GSM8K stands for Grade School Math 8K, and it's one of the most commonly used benchmarks for LLM reasoning and problem solving. You'll see it quoted in all the big model releases. And it consists of a few thousand problems, arithmetic word problems of roughly elementary school difficulty level. And you'll notice a few interesting things right away, which is that past about early 2023, these scores really flatten out. So back in April 2023, the highest score was about 93%, and then we went up to 96.5, and right now, a year later, in mid 2024, the top two scores are 97.1 and 97%. So it really seems to be saturating out. So I was curious about the approaches taken by the leaders on this leaderboard. And so let's go ahead and look at the top two. So this is the approach, deeply understanding the problem, that is currently number one on the leaderboard, 97.1% on GSM8K. And if you look at it, their approach is actually pretty simple. As the name applies, the idea is to deeply understand the problem, and they're really trying to mimic what a human might do when trying to solve these kinds of math problems. And there are three steps to it. The first one is to understand what the main question is. Step two is extracting the relevant info from the problem and ignoring all the incidental details. And then step three is finally solving it. And they carry out these steps with a series of prompts to the LLM itself. Step one is, given the question, extract the core question. And step two is where they take the question, they append the core question that the previous prompt extracted, and add on an instruction to only extract the most useful information required for solving this problem. And then finally, the third prompt is to concatenate all of these things, the problem, the core question, the relevant information, and then ask the LLM to solve the question. And this approach gives them the leading 97.1% score. But note that compared to zero-shot chain of thought prompting, the gap isn't that big. So zero-shot COT gives you almost 95%. So they got about 2.5% on top of that with this approach, which utilizes two additional prompts, so two additional inferences. So they're paying for that 2% with a lot of extra compute. So that was number one. Let's go back and look at the number two paper on the leaderboard, which is just barely behind. It's 97.0 as opposed to 97.1. And this paper is using the insight that it is much better to generate code to solve these kinds of math problems and then run the code to get the answer, or to get feedback if the LLM's answer differs from the code's answer, than to directly ask the LLM to solve the problem. So if you use GPT-4 on the web through their chat UI, it will automatically give you its code interpreter feature, which means that behind the scenes, for problems where it might help, it will go ahead and automatically generate and execute code to solve your problem without you having to ask for it. What the authors are doing in this paper is kind of reverse engineering that functionality and trying to tease out how much of the solution of things like GSM8K depends on that code generation feature versus not. And the way they're doing that, once again, is by prompting. So they have several variations of their problem-solving prompt, where in the first variation, they ask the model to not generate any code. And so that's where the LLM itself is solving the given problem. In a second variation, they ask the model to use code only once. So the model can't refine its code or try to debug its reasoning if the code's answer differs from the model's answer. It's really interesting to note how GPT-4 is smart enough to use SymPy and use symbolic reasoning for these kinds of abstract problems. And here you can see their not too surprising result, which is that in these variations of prompts, as you allow more and more coding, you get higher and higher accuracy. And these prompt variations 1, 2, 3, 4 are where the first variation is no code. Number 3 is just the basic prompt. Number 2 is where you can use code only once. And number 4 is where you verify your answer with code interpreter. And as you allow more and more prompting and debugging with code, you get higher and higher accuracy. And then to increase their accuracy even more, they go one step further and take multiple samples from the model. So they ask the model to generate solutions multiple times, and then they take the majority answer out of all those samples. And this is the final result, where with code interpreter plus self-verification plus majority voting, they score about 97%, exactly 97% on GSM8K. With their GPT-4 with 15 samples, you get about 96.8. And with simple GPT-4 code interpretation, you get about 93%. So you can see how all these approaches are kind of clustering together at the top, and they're all within a few percentage points of each other. So this might be good news or bad news, depending on how you look at it. The good news is that you're pretty much saturating out on these benchmarks. But then the bad news, so to speak, is that the goalposts keep moving as you saturate out these simpler math problem-solving benchmarks. People are creating benchmarks with more challenging math problems, and a lot of those LLMs are not very good at yet, or at least not good enough to get scores in the high 90s. So that was a quick look at how LLMs are doing on GSM8K, which is really well, even with fairly simple approaches, and the really complex approaches only add a few percentage points over the simple approach. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you next time. Thank you very much.